Well, hi, guys and gals. Hope everyone's doing wonderful today. We're going to do a short video today over the P-series. A P-series test is probably the quickest way to tell if a series converges or if it diverges. And so we're going to take a look at this fact here, the P-series test. As long as you have a series going from 1 to infinity, 2 to infinity, 4 to infinity, and if your fraction is 1 over n to a power of p, this is going to converge if that power is bigger than 1, and it's going to diverge if that power is less than or equal to 1. Now, notice that this does not tell us what it converges to. That's going to be a lot harder later. But it does at least tell us if it converges or not, if it converges or if it diverges. So let's just take a look at some examples. What about from n equals 1 to infinity of 1 over n to the 7th? This is a direct application of the P-series test. I have the form 1 over n to the p. Here, this is a P-series, and I have p equal to 7. And this is obviously bigger than 1. So if this exponent on the n is larger than 1, then you are going to say that the series converges. Well, let's see another example. What about the summation from 1 to infinity of 1 over the square root of n? Well, this is also a P-series. You're just going to have to write this square root as a fractional exponent. So this could be the same thing as n equals 1 to infinity of 1 divided by n to the 1/2 power. This is a P-series. It's 1 over n to a power. This is a P-series with p equal to 1/2. 1/2 is less than 1. Therefore, this series, by our fact, diverges. Let's see. What about summation from 1 to infinity of 7 times the cube root of n over n squared? Now here I can take my 7 all the way out in front of the sigma, and then I can write this as n to the 1/3 power over n squared, and then I can apply my rules of exponents. If we have this like base and we have exponents, we can subtract those. So let's see what that works out to be. Let's see, we subtract these 1/3 minus 2 is, what is that, negative 1 2/3? Is that right? Or negative 5/3? So n to the negative 5/3 is the same as 1 over n to the 5/3. And here I have a series, and it's a P-series. And so my p is equal to 5/3, which is larger than 1. From our fact, if this exponent is bigger than 1, then this is a convergent series. Now, even though I'm multiplying times 7, I'm multiplying 7 times something that I know adds up to a finite number. 7 times a finite number is still finite. So this series converges. Now notice I do not know what it converges to, and I'm not going to tell you. I don't even know what that converges to, but we'll investigate that later. We at least know that it converges. Okay. What about summation from 1 to infinity of 1 over n? This is a P-series. What's the exponent on this n? Well, it's a 1. So it's a P-series where the p is equal to 1. And you look at our fact, if the p is less than or even equal to 1, this is going to diverge. And this series right here has caused me to lose some sleep. If you want to, on your calculator, play around with this and look at, like I showed you guys today, and look and graph it, go to your parametric mode and graph this parametrically, graph this series, you'll see that it does so very slowly, but this does diverge. And that's almost hard for me to believe when I first studied this. And this has a special name. This is called the harmonic series. Now, if you are in music, you might know that these numbers that are formed from the series. If we plug in 1 and then 2 and then 3 and then 4, these fractions are where your harmonics are if you have an acoustic string. There's one at halfway up and one at third way up and a fourth of the way up and dot, dot, dot. And the harmonic series, if you add these numbers up, it takes a long time, but it does go to infinity and it diverges. So that's it. That's the piece series. And I don't have anything else than that. So tomorrow we're going to practice that, and I will see you guys then.